Hi friends, welcome to Free CCNA Packet Tracer Labs for Beginners. In this video, we are going to learn IPv4 inter-VLAN routing using multi-layer switch. Friends, before coming to this lab, if you wish to get this type of CCNA videos, consider subscribing. And also don't forget to enable the bell icon so that you will not miss any future videos. And also, if you wish to get any technical support, you can contact our team. All the details are given in the description below. Here is our Cisco Packet Tracer. First of all, we will design the topology. We needed a multi-layer switch, so 3560 series. Then a 2960 series switch. Then some edge devices, PCs. We will rename all these devices for understanding purpose. Consider this is MLS. This is S1. Student PC1. This is student PC2. Staff PC1. Staff PC2. Connect all these devices. Connections, we will choose copper crossover to connect multi-layer switch and S1. We will connect 2 gigabit Ethernet 0/1 to this S1. Gigabit Ethernet 0/1. Then we will choose copper straight through to connect all these PCs from S1 fast Ethernet 0/1 to this student PC1. Then FA 0/2 to this student PC2. FA 0/7 to staff PC1. FA 0/8 to this staff PC2. Here, before coming to the configuration, we will update our addressing table and VLAN table. First of all, we will update our VLAN table. We will have some VLAN IDs. Okay, we will take VLAN 100, VLAN name, students, device or port number. So we have to create these VLANs on both switches in multi-layer switch as well as our S1 layer 2 device. So here S1 interface FA 0/1-6. Also, we have to create this VLAN ID 100 in multi-layer switch also. Then VLAN ID 200, staff, S1 FA 0/7 till 12. Also, we have to create this VLAN in MLS. Also, we will create for native and unused ports. We will have 250. This is for native. On S1 as well as MLS, G0/1 should be configured as a native. Then VLAN 300. This is for unused. S1 FA 0/13 till 24. Also G0/2. We will update our network table. We will plan some IP address for this VLAN ID, student and staff. VLAN ID 100, students. So we will have network address 10.10.10.0/25. VLAN ID 200, that is staff. We will use 10.10.10.128/25. Now we will update our addressing table. Device, we have MLS. Then interface, here we are going to set IP address for the VLAN, that is SVI, switch virtual interface. So here we have VLAN 100, also VLAN 200. For VLAN 100, we will use the first usable IP address from the subnet, that is 10.10.10.1, then subnet mask. Here default gateway is not applicable. And this address, it is 10.10.10.1, will be the gateway for VLAN 100, that is students. So gateway for VLAN 100 students. Next is VLAN 200. We will use the first usable IP address from the subnet, 10.10.10.129. Then subnet mask. Default gateway is not applicable. Description, this is gateway for VLAN 200, that is staff. We have 4 PCs, student PC1, interface NIC, then IP address. We will use the last usable IP address from the subnet, 10.10.10.126, then subnet mask. Default gateway, so here we can see 10.10.10.1 for VLAN 100. So this student PC1 is connected to S1 FS0/1. Then we have student PC2, interface NIC, IP address. We will use 125, the second last usable IP address. Then subnet mask. Default gateway 10.10.10.1. And this student PC2 is connected to S1 FS0/2. We have staff PC1, interface NIC. Here we will use the last usable IP address from the subnet, VLAN 200, 10.10.10.254. Then subnet mask. Default gateway is here. And this staff PC1 is connected to S1 FS0/7. Then staff PC2, interface NIC, IP address. We will use the second last usable IP address, it is 253. Then subnet mask, default gateway, and description. This staff-PC2 is connected to S1 FS0/8. Okay, all our documents are ready. Now back to our packet tracer. We will configure each devices one by one. MLS, then S1, then entity devices. So first of all, we will configure S1. We will create the VLANs, then we will assign ports to its respective VLANs. Go to S1, CLI, enable, configure terminal. We will set the host name S1, then create the VLANs. We have VLAN 100, name students, VLAN 200, name staff, VLAN 250, name native, VLAN 300, name unused. Next, we will assign ports to its respective VLAN. You can refer the VLAN table. First of all, we will go to interface as a range FA0/1-6. Switch port mode access, switch port access VLAN 100. So this student-PC1 and student-PC2, they are in VLAN 100. We can label that here. Then we will go to interface as a range FA0/7 till 12. Switch port mode access, switch port access VLAN 200. Then we will go to all the unused ports and will assign to VLAN ID 300. Interface as a range FA0/13 till 24. Also we have G0/2. Switch port mode access, switch port access VLAN 300. We can shut down all these unused ports. Also, you can set some description for all these unused ports. Even we can set a description for all the interfaces if needed, because it gives information about the interfaces. Now we will assign IP address to these PCs. First of all, coming to student-PC1 desktop IP configuration. So here we will give 10.10.10.126. So we can refer our addressing table. Then submask, default gateway, coming to student-PC2 desktop IP configuration. (125) submask, default gateway, then coming to staff-PC1 desktop IP configuration, submask, default gateway, coming to staff-PC2 submask, default gateway, Here same VLANs are ready to communicate. We can see this is VLAN 200. This is also in VLAN 200. Here this student-PC1 will communicate to student-PC2 because they are in the same subnet. Staff-PC1 will communicate to staff-PC2. They are in the same subnet. We can test it. 10.10.10.125. So here we can see we get the replies. Also staff-PC1 command prompt 10.10.10.253. Here we will try to ping to student PC1 or student PC2, and it will not communicate because they are in different subnet. We have to configure inter VLAN routing. We will try to ping to student-PC1, that is 10.10.10.250, sorry, 126. No, we are not getting the replies. It's a request timed out. It's not going to communicate. Now we are going to configure inter VLAN routing using multi-layer switch. So here we are going to configure this MLS CLI. Now enable configure terminal. We will set the host name as MLS. We know it is a switch. By default, multi-layer switch act as a layer 2 device. So here we are going to enable IP routing. So we must give this command IP routing. Then we will create all the VLANs. VLAN 100, name is students. VLAN 200, name is staff. VLAN 250, name is native. Then we have VLAN 300. This is for the unused ports. Name is unused. In this multi-layer switch, we used only one interface, that is G0/1. We can shut down all other interfaces. Interface as a range FA0/1-24, then G0/2. Switch port mode access, switch port access VLAN 300. I need to type it correctly. Switch port access VLAN 300. Okay, we can shut down all these ports. Then we will configure this SVI, switch virtual interface. So we will go to interface VLAN 100. So interface VLAN 100 changed state to up. So no need to give the no shutdown command. Here we will set the IP address 10.10.10.1. So this is the address we planned. Then subnet mask. If needed, you can set the description. Okay, so here I will go to interface VLAN 200. Interface VLAN 200 changed state to up. Then set the IP address 10.10.10.129 with the subnet mask. Now here we can see we connected from S1 to MLS using single cable. So this connection, this link between S1 and MLS should be trunking. It should be trunking on both sides, S1 G0/1 as well as MLS G0/1. So first of all, we will go to S1. Enable configure terminal. You will go to interface G0/1. Switch port mode trunk. Also, we will set the native VLAN. Switch port trunk native VLAN 250. Also, for security reason, we can configure the allowed VLANs. Switch port trunk allowed VLAN. So in between we get some message native VLAN mismatch discovered on a gigabit Ethernet 0/1 250 with the MLS gigabit Ethernet 0/1. So it's a mismatch with the native VLAN. We have to configure a native VLAN on the other side also in this MLS G0/1. We will do that. So no need to worry about this warning. Just to press tab button from the keyboard so that we will get the command we were entering. So switch port trunk allowed VLAN 100, 200, 250. We will go to multi-layer switch, and here also we can see that message native VLAN mismatch discovered on gigabit Ethernet 0/1. So here the native VLAN is in default native VLAN 1. So we must change it. We will go to interface G0/1 and manually we can configure the trunk. Switch port mode trunk. So here when you give a switch port mode trunk, you will get again another message. So it says command rejected. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. So here we have to give this command first. Switch port, we have to change its mode from auto to desirable. Switch port mode dynamic desirable. So here we can see interface gigabit Ethernet 0/1 changed state to up. Then we will configure switch port trunk encapsulation .1Q. Then manually we can configure to trunk. Switch port mode trunk. Also we can set the native VLAN. Switch port trunk native VLAN 250. So once you give this command, here we can see this inconsistency restored, unblocking gigabit Ethernet on VLAN 250 port consistency restored. Perfect. Switch port trunk allowed VLAN 100, 200, 250. End. Copy run space start. Here also we will save the configuration. End. Copy run space start. Now these PCs are ready to communicate. We will ping from student to staff. So coming to student PC1 command prompt, we will ping to 10.10.10.254, that is staff PC1, and we are waiting for the replies. So here we can see we get the replies. Now we will ping to staff PC2, that is 253. we may get one request timed out due to convergence. Yes, so it's working. Even we can ping to its default gateway, VLAN 100 default gateway, that is students, then VLAN 200 default gateway, that is staff, it's 129. Perfect. So friends, in this video we configured IPv4 inter-VLAN routing using multi-layer switch. If you get any doubt or any suggestions, you can comment below, or even you can contact our team. All the details are given in the description below. Stay tuned. We will meet again with the next video. Thank you.